In this video, we will study stress-strain diagram of concrete under compression, and also we will see the characteristic strength of concrete and how different factors that are applied to characteristic strength so that it can be taken into the design problem. You can see the figure. Some part of the stress-strain diagram is parabolic and other part is the straight line. The parabolic part is from 0 to 0.002 strain value, and beyond 0.002 strain value the stress strain diagram will get into straight line. Now FCK is the characteristic strength of the concrete. The value of FCK it depends on the grade of concrete. For M20 grade concrete, the value of FCK is 20 Newton per mm square. So in the design problem, you see FCK value is not taken as FCK for two reasons. We will see it one by one. The point is that FCK is reduced and that the reduction of FCK is taken in the design problem. First is from FCK to 0.67 FCK. And one more thing, you see, the maximum strain in concrete, here it is written, the maximum strain in concrete is 0.0035 as per the assumption given by IS 4562 for limit state method. Now we will see the reason for reduction from FCK to 0.67 FCK. Here the size factor is applied. Now there are large difference between what is casted at the site, the beams and the columns that are casted at the site, and what is tested in the lab. Now several studies have indicated that 0.85 should be multiplied with FC dash. What is FC dash? FC dash is the cylindrical strength of concrete. 0.85 is taken to consider the difference between what is casted at the site and the cylindrical specimen which are tested in the lab. Okay, so now in India you see the cubes are tested instead of cylinders. So one more account we have to take, the count of cylinders and the cube, because they are different in size. So the cylinders are tested in countries like USA, UK for determining compressive strength of concrete. We also have to consider one more size effect from cylinders to cube. The relation between the cylindrical strength and the cube strength is 0.8. Cylindrical strength is equal to 0.8 times the cube strength. So we have considered two accounts. One is the size difference of beam column and the cylinders, and second is size difference of cylinders and the cube. So we have to multiply these two accounts, 0.85 and 0.8. 0.85 is the first account and 0.8 is the second account. So the value comes to 0.67 FCK. Now again this value of is reduced to 0.45 FCK. One more reason we need to see, for what reason the value is further reduced from 0.67 FCK to 0.45 FCK. In LSM, in limit state method, you see partial safety factors are applied to the material. It is denoted by gamma M. For concrete, we can take it as gamma MC associated with the concrete. For you see, for concrete in RCC we have two material, concrete and steel. For concrete the partial safety factor is 1.5 and for steel it is 1.15. In some day we will see the reason why it is less for steel, why it is more for concrete. Now when the partial safety factor is applied to the concrete, the value comes to 0.45 FCK. Now see, many of the students, when they solve the design problem, they directly take 0.45 FCK instead of understanding how 0.45 FCK is coming. Even the professors of many institutions are not teaching how this particular value of 0.45 FCK is coming. This video is a small effort from my side to show you how 0.45 FCK is coming. I hope that you enjoyed it, and thanks for watching it.